Hello, we are going to solve another exam question. This is from paper 1 for future standard and higher level students. That means it's without calculator. And it's from section B, which means it's a bit of a longer question for a total of 12 marks. So now you should stop the video and read exactly what the question is asking for you, not just the first part that you're going to solve first, but just the whole question to have an idea of what's going on. So now you know that part A and B are asking you to write equations of lines, and then in C you have to find the intersection of those two lines, and then in D you're going to have to do a scale sketch complete with all the labels of everything, and then at the end you're going to be finding a distance. This is optional, but something that I may like to do is a quick sketch of what is that we're going to be doing, just to keep it here. This is not the sketch they're asking us in part D. This is just a very quick sketch just for me to keep track of what we are doing. So there is a point -2, -3. You see, I'm not being very careful here. It's just a sketch of a sketch if you want. And then 3, 7. So this is the line over here. And that's the first thing we're going to write, the equation of that. Then there is another line at the point going to the point 3, 2, and perpendicular to this. So something like this, perpendicular. When you give name, this was Q. First line was L, this one is P, the point Q. Then the point of intersection of the two lines is here. That's I. And then they are going to ask us for the distance between Q and the line L. So from this point Q to the line L, well, the distance is going to be going through the perpendicular. So actually we're going to be finding the distance of this small segment over here. Okay, that's a plan. Now we know what we're going to do, so let's do it. We begin part A. We know 2 points, -2, -3, and 3, 7. And we want the equation of the line going through that. To write the equation of the line, usually we use the slope y-intersect form. So we need to find the slope. So we need to find the difference between the y-coordinates divided by the difference between the x-coordinates. So I'm going to use a color here. We have here one y-coordinate and here the other. So I'll write here. We can decide which one we put first. I'll just put the positive one. So 7 minus -3. That's the difference between the y-coordinates. And now we need the difference between the x-coordinates. And we have to respect the order we used before. So if we use the 3 from the second point, the 7 from the second point first, then now we need to use the 3 from the same point. So if this one came here, then this comes here. So 3 minus -2. This is 10 divided by 5. So this is 2. And let's check that this makes sense. We have a small sketch over here where it looks like the line L is increasing. So that makes sense. We can also check when we are in -2, we are at -3 negative in the third quadrant. And then when we are in 3, we're in 7 positive in the first quadrant. So yes, our line is going up. So that result too so far makes sense. So what we know so far is that y is equal to 2x plus something, we don't know what it is. From our picture, we can see over there it looks as positive value, but not very big. In any case, it has to be less than 7. But we need to find exactly what it is, and we are not going to rely on the sketch, not even in the good one with scale and ruler and everything, to find b, because in the sketch it may look like the solution is 1, but if the solution is 0.9, we wouldn't see the difference. So we need to instead use the equation we have so far that is not complete over here, and one of the points we know, for instance, the point 3, 7. We know that the point 3, 7 belongs to the line L. So that means when x is equal to 3, so instead of x we can write 3, then y is equal to 7. So we are saying that 7 is the same as 2 times 3 plus b. So 7 is the same as 6 plus b. Then we know that b is equal to 1. And now we are ready to write that the line L has equation y equals 2x plus 1. And that was what was asked from us from part A, and I'm just going to write it over here because I may need to erase to get more space. So to keep track, let's keep here the equation of L. Now we need to write the equation of the line P. P is perpendicular to L. Remember this symbol to say that it's perpendicular. So we know that if we know the slope of L, to find the slope of P, so let me write MP, we need to take the reciprocal, so a half, and we need to also change the sign, multiply by -1. So it's going to be negative a half. So this is the slope of the line P, which is perpendicular to a line L. And we can see in our picture that yes, P has to be a decreasing line with negative slope. So far we know then that for the equation of P we have y is equal to minus a half of x plus, well, something, I'll call it c. And we need to find what that c is. But we just did that for the other line, so we know how to do it. We need to use what we know about the equation so far, and we need to use the fact that the point Q with coordinates 3, 2 belongs to our line P. So again, when x is equal to 3 over here, then y has to be equal to 2. So I'll write this down over here. 2 is equal to negative half times 3 plus c. And we need to find the value of c. So let's isolate c. We have that 2 plus 3 over 2. I just multiply over here. The negative half times 3 has to be equal to c. But if we want to write 2 with denominator 2, so we did write 4 over 2 plus 3 over 2 has to be equal to c. So we found that the value of c is 7/2. So the line P has equation y equal negative half times x plus 7/2. And I'll write again the equation over here to keep track, since I'm going to need more space over here. So I'm going to erase over here. So we get space, so we can find what is the intersection of the two lines. Let me write the equations of the lines again. We know that for the line L, y is 2 times x plus 1, and for the line P, y is negative half x plus 7/2. And we want the point of intersection, so that means we want both things to be true at the same time. So I'm saying y is equal to blah, and y is equal to blah blah. And this means that blah and blah blah are the same. So what is on the right hand side of each equality has to be equal. So 2x plus 1 has to be the same as negative x plus negative half of x plus 7/2. Note that what we have here when we write the two equations of the line is what we call a system of equations, because it's two equations together and they are linear, both of them are linear equations. And we have two unknowns, x and y. What I did by equating the right-hand sides of the two equations was to get rid of the variable y. So now we have only one equation that is linear and only has the unknown x. So we can solve this. We're going to have everything with x on the left-hand side and all the numbers on the left-hand side. So 2x plus half of x has to be the same as 7/2 minus 1. So this is 4/2 of x plus half of x has to be the same as 7/2 minus 2/2. So 5/2 of x has to be the same as 5/2. So x has to be equal to 1. Now we know the value of x. We need to find what is the value of y. So we found the x coordinate of the point of intersection. We need to find the y coordinate. But we know that the point belongs to the lines, for instance, to the first one. So y is going to be given by 2 times multiplied by 1, because 1 is the value we found for the x coordinate, plus 1. So y has to be 2 plus 1, which is y equals 3. So our point of intersection I is the point 1, 3. Okay, I made a little bit more space for our sketch. We have to look at the numbers. We have to have an idea of how big we need to make each of the quadrants. And from what I see from the points we have, we need quite a bit in the positive y-axis. So let's see over here if I can fit everything. Here we need to be able to see. Oh, this is not. Sorry for the technical problems. Okay, we need to have the point -2, -3. 1, 2, 3 here. That's one of the points the line L goes through, and the other point is the point 3, 7. So that's the reason why I needed to do the positive y-axis a little bit bigger. So here, 0.37. That's going to be the points I have to make the line L go through. So let's make a line over here. There. Okay, I'm gonna extend it a little bit in this direction, even if it doesn't look perfect, because we want a line, not a segment. For the line P, let's change color. We know the point 3, 2, and we know it has to be perpendicular, but that's a little bit hard to decide. We also know that the y-intercept is at 3.2, 3.5, 7 divided by 2. So let's mark over here 3.5, and let's make the line going through those 2 points. I think it's a bit easier. Yeah, well, I'm sure with a ruler you're gonna be having less trouble than me with this. Okay, but more or less this is the line P, and this is the point Q. I forgot to write the name of the other line. This is the line L. The other 2 points didn't have names. I don't need to add them. Let's see if this confirms what we found already. For the line, let's write the line L first. Let's take a point, like for instance, the point over here. Yeah, this is the point of the line. This is the point 2, 5. And then I go 1 step to the right, and then I have to go 2 steps up. So this confirms that we found the slope to be 2. And we can see here the y-intercept definitely looks to be at the point 1. So that's good. For the line P, we used the y-intercept we wanted to get, but we can see if the slope looks fine. If it looks like when I go 1 step down, I go 2 steps to the right, and yeah, it looks like that. So that confirms what we have so far. Also the point I, the point of intersection, we want it to be the point 1, 3 according to the algebra, and we confirm that here in the picture. So we check that everything is okay so far. So now we just need to find the distance from the point Q to the line L, and this is the distance from the point Q to the point I, because we know that P is perpendicular. So let me write here the coordinates of Q were 3, 2, and the coordinates of I are 1, 3, and we need to apply the formula. So we need to look at the difference between the x coordinates, so 3 and 1, so 3 minus 1 square, plus, and then we need the difference between the y coordinates, 2 minus 3 square, and then we need to take the square root of all of that. And this is 3 minus 1, that's 2 square, 4, plus 2 minus 3, that's -1 square, 1 square root of that. So this is square root of 5. That's the distance between the point and the line over here.